Hi everyone, I'm Katarzyna and this is question 4 for HAP 725. I'm going to walk you through how I pulled the Hospital Compare HCAHPS data, cleaned it in Python, and then compared Sibley's patient satisfaction to other DC hospitals using an X-bar control chart. So here's our problem. The goal is to download all available quarters years from Hospital Compare. Use the file, focus on the measure, which is HCAHPS linear score, which is the linear mean of patient ratings from 0 to 100. Then I compare Sibley to its DC competitors using the facility IDs listed in the prompt. And answer, is Sibley performing better than the other competitors? Here's our roadmap. I download and unzip the HCHPS files, process the data sets in Jupyter, filter to the measure and the DC hospitals, clean the numeric values, compute averages and variability, and then build control limits and plot an X-bar chart. So when you open the link, this is how it is going to look like to download the zip files. So you're going to select the files for 2019 to 2023, download them onto your computer, unzip them, and then extract the specific HCHPS hospital data sets for each folder. So for the processing, I am using my Anaconda and loading up Jupyter Notebook. So step 1, load the data. Here I import the libraries that are necessary, load each yearly CSV in its own data frame. I also include engine equals Python to avoid common Unicode decoding errors. At this step, I print column names for each data frame. The purpose is to confirm the exact headers because Hospital Compare files can change column names across years. So this is our output. After running that line of code, you will see that in 2023, the city column is named city town instead of city. If you don't account for that, the filtering step would fail or return empty results. Next, we're going to select our specific columns that we need, which is facility ID, facility name, city or city/town, HCHPS measure ID, the linear mean value, and start and end dates. Here's the output for that line of code. It shows the clean, smaller data frame. This is important because it prevents errors later and keeps the analysis focused only on what matters. Next, we're going to check our data types. Most importantly, I want to check if the satisfaction score column is being read as a numeric or a text. So as we could see, our data types are all objects, and if it's not numeric, we can't compute means, standard deviations, or control limits correctly. So in step 5, we're going to check whether satisfaction column can be successfully converted to a float. This is where we usually discover values like not available that break numeric calculations. So this is our input. And this is our output, shows value error, confirming there are non-numeric strings in the satisfaction column that must be handled before analysis. So in this step, we replaced not available values by converting the column. That turns non-numeric entries into NaN, so the column can be treated as numeric. So this is our input. And we're going to run this to see the updated columns now. So this is our output. It confirms that the satisfaction column is numeric now, so I can proceed with calculating means and variability. We are going to just do one last sanity check, correct columns, expected measure ID, and obvious no structural issues. So here we're going to apply key filters. So we're only keeping the measure HCAHPS linear score. We're going to filter DC hospitals using the facility IDs from the prompt, and then filter to the DC city category like Washington. I do want to note that facility ID 90006, which is Providence Hospital, is no longer available in the most recent data sets because it is no longer an active hospital, so we're going to remove that from our facility IDs. So this output confirms the filter worked. I see only the hospitals I intend to compare and only for the correct HCHPS measure. So we want to check our data frame. This step is to make sure that after dropping Providence, we still have the 7 hospitals, including Sibley, so shape should be 7-7. So step 9A, we're going to calculate the average satisfaction for Sibley. And then in step 9B, we're going to calculate the average for the rest of the DC hospitals. In step 10, we are combining the yearly satisfaction values into one combined structure, so it's easy to compute overall averages, standard deviations, and later build control limits. Next, we're calculating average and standard deviation. We want to calculate the grand average and the overall standard deviation across years. These become the center line and the variability estimate for the control chart. So in step 12, we're creating a data frame for the DC hospitals year by year, which I use for distribution checks and summary stats. So this is our normal distribution. Here in step 14, we're computing the mean and standard deviation for the DC hospitals values, which feeds into the standard error and the control limit calculations. In step 15, we are counting DC hospitals. This matters because the control limits use the standard error, which depends on sample size. I also set Z to 1.96, which corresponds to a 95% interval. Step 16 includes assembling a table that includes the year, Sibley's mean, the DC mean, the standard error per year, the overall mean, and the Z statistics, so I can calculate the upper control limit and the lower control limit cleanly. So in step 17, we're converting the list into a data frame and add clear column names. This makes the results readable and ensures the next calculation reference is the correct fields. So in step 17, we are calculating the control limits. These represent the expected range of variation for the D hospital process year by year. Step 19, finally we plot the X-bar control chart. Sibley's yearly satisfaction mean is the main line, and the upper and the lower control limits. This final chart is the key result. If Sibley's points are consistently above the DC competitor mean and approach or exceed the upper control limit, that suggests Sibley is performing better than expected compared to DC variation. And if Sibley stays within the control limits, then differences are likely within normal variation, meaning Sibley is comparable to its competitors rather than cleanly better or worse.